Okay, Assalamualaikum. I will continue our explanation about the lab sheet 2, selection of condenser water pump for water-cooled package unit. So this session just continue our my explanation before this. Alright, okay. So in order to do the selection of the condenser water pump, you need to know about the procedure to make the pump selection. Okay, first one, for pump selection procedure, first establish piping design. So you already know the piping supply and return from water-cooled package unit to cooling tower. Condenser water return, and then from cooling tower to package unit is condenser water supply. Alright, so from the supporting document that I given to you, you can find your piping length. Okay, and then second step is find the size of the piping. Okay, also give to you the piping size, because but you need to have you need to convert it to inch, because I give you in millimeter unit. Because when using vernier clipper, the value the unit will appear in millimeter, so you need to convert to inch. So and then third step, calculate the pressure drop. So you need to know also what any valve or fitting attached at the pipe. So please bear in mind, you need to select the condenser water pump at condenser water supply piping. So just the length that I given to you is the length of condenser water supply piping only. Okay, so forget it about the return. So next, after you get the pressure drop, so basically we use a 15% safety factor of the friction loss, because we already know after the system is run for how many time, how many years, so it would be a corrosion inside the pipe. So due to that reason, because of corrosion, so the diameter of the piping will be reduced. Okay, so due to the reason, we need to additional 50% of the friction loss. And then once you know the final friction loss value, and then you can use pump curve to select a pump suitable for the system. All right. So from your task also, you need to do a sketch about the layout from the package unit to the cooling tower. All right. The whole complete schematic. All right. Okay, so we go step by step. Okay, from your supporting document, from your supporting documents, please refer for your objective. All right. And then for your operation procedure, how you run the system, how you do data collection, just refer to the video that I posted in Ulearn. And there is 5 tools that I have used for this lab session, which is measuring tape to measure the piping length, a vernier clipper to measure the diameter of the piping and also the fittings, and EVM abundant monitors need to measure temperature and relativity at return grill. And then anemometer is to measure velocity, and also you can also can know the temperature of the supply air from the diffuser. And then last one is bolometer. This one I forgot to attach it in the video. So bolometer is to use to measure the air flow rate at the diffuser. Basically, we use this bolometer for 2x2 diffuser. 2x2, we call it that diffuser. Ini diffuser. Wait, 2x2 is square diffuser. Right. So you use bolometer to measure the air flow rate, directly get air flow rate, and you need safe M. For anemometer, you can have the data of the velocity, air velocity, in unit meter per second or feet per minute. It depends on your setting lah at the equipment. And then you need to times the area of the diffuser, and then you get Q. Q is air flow rate. Alright. So from table 1, I already give you the velocity of the all 8 diffuser. Okay, you can see from the left table, left column A until hash. So the value of the air velocity, 3 data, and you need to find an average. And the diffuser size I give you in unit centimeter, so you need to convert it to feet in order to place your result here, your calculation here. So make sure this data you fill in with unit feet square. And then air flow rate is cubic feet per minute. So if I stated here cubic feet per minute, so by right you need to have the velocity value in feet per minute. So you need to convert it meter per second to feet per minute. And then times feet square, so then you can get CFM. Alright, so just fill in this table. So for second table, just identify the equipment and tools used for data measurement. So for supply air temperature, 3.2 degrees Celsius, this one is data I get from for you. And then the unit is degrees Celsius, and also return air temperature at 14 degrees Celsius. And then supply air temperature ni, I use an anemometer to measure actually. Actually, when we talk about the temperature, we can have to measure using thermometer also. And then, for anemometer, there has 2 data will appear on the screen, which is velocity and also temperature. Okay, so for this, quite simple for table 2, alright. Okay, and then for table 3, piping and fitting. So I already give you any type of valve and fitting attached at the piping. So for the first info, you need to know the length of the piping, like I said just now. So the length of piping is only focused on where is your pump, location of the pump at the piping. So this is condenser water supply lah. So 122 feet the length, and diameter is 61 mm. So all the diameter for this valve and fitting, I'll give you in millimeter. Then you need to convert it to inch, because you need to use the friction loss chart in unit inch. So you need to convert it millimeter to inch. So you also need to know about the quantity of the fitting. So such as gate valve 3 unit, strainer 1 unit, and elbow 90 degree 11 unit. So all these 4 items, the last 4 items, vibration oscillator, temperature indicator, pressure indicator, and flow rate meter, I didn't give any diameter here because this 4 items is not included in the calculation of the piping loss. Alright, so your task is, first one, you need to refer the quantity and the diameter, the data provided in table 3, and then complete it in appendix A. Appendix A is table for calculation of heat loss. And then second task is draw the complete schematic. Complete means full complete supply and return piping. From water qualification unit to cooling tower. Okay, and then refer to appendix B. And then third one, please propose the suitable condenser water pump based on your data from number 1. So you need to use pump curve at appendix C to support the answer. Okay, so we start with this one first. So I will teach you how to calculate the pressure drop. Alright. Okay. So appendix A. Okay. So first one you need to put piping. So how many length of your piping? Okay, first one, before that you need to know the diameter. Okay, diameter I give to you is, let's say, this one example only. Okay, let's say 60 mm. Let's say, then inch, 60 mm is 2 inch. Okay, let's say 2 inch. Alright. And then flow rate US gallon per minute, US GPM is US gallon per minute, flow rate of the condenser water. So you can get it from the lab sheet. Okay, so next slide. Okay, so your model is, your water qualification unit model is WCPU EWM 000. So please refer to the catalog given. Okay, model 100 EWM 100, and then go to condenser, refer here, water flow rate in unit US gallon per minute. So the value is 25.4 gallon per minute. Okay, so 25.4 US gallon per minute. So you need to know the velocity, kelajuan air dalam piping tersebut. Jadi please open the friction loss chart. Okay. Okay. So this one we call is friction loss chart. So for info you can get from this. First one is flow rate in unit US gallon per minute. So this value 0.5, 1, 2, 3, 4, 6. Okay, this one. And then second one is head loss, feet per 100 feet. Start from 0.5 until 30. Okay, this one is straight line. And then third parameter is velocity, water velocity. This one is FPS, is feet per second. 1 FPS, 2 FPS, 3, 4, 5, 6. Alright, and then fourth parameter, which is the last one, is piping diameter. This one is 2 inch, 2.5 inch, 3 inch, 4 inch. Okay. So basically you have two data actually. You have 25.4 water flow rate, 25.4 water flow rate. Just draw a straight line, attach it to the piping size, pipe size. Okay, let's say you count, you get, after you convert from millimeter to inch, you get 2 inch. Okay, let's say 2 inch. 25.4 US GPM straightly, just intersection next to 2 inch pipe, and just draw a this one is velocity, right? This one is slanting. Alright, so this one is attached here, intersection here. So what is the velocity? Okay, around 2.5 feet per second. So just input here 2.5. Okay, let's say 2.5. 2.5 feet per second. Alright. Okay, then next. For piping, there is no equivalent length. This equivalent length just used for fittings only. So just put dash. Okay. And then also dash for quantity. See this A and B used for fitting only. Okay. Alright. And then what is the total length of your piping? Length of your piping is, okay, get it from supporting document. Your piping length is 122 feet. 122 feet. Okay, unit here is feet. 122. Okay. 122 feet. Alright. And then friction loss of the pipe from your friction loss chart. Okay, 25.4 US gallon per minute. Intersection here at 2 inch piping. Just draw it up. Okay, and then you get around 1.5 feet per 100 feet. This one is friction loss for piping only. 1.5. And then put it here. 1.5 feet per 100 feet. Okay. Alright. So, first one, you need to do the piping. Second one, so what are the fittings that involve in the piping? So, first one, okay, let's say you have gate valve. Gate valve. Alright. Okay, diameter of your gate valve, please find it in the supporting document. So, flow rate is just dash, no data here. And also velocity is no data here. And then for Okay, we continue for part 2. So we just finished the piping, and then for second one. So what any fittings attached in the piping? Okay, let's say you have a gate valve. Okay, let's say you have a gate valve. Okay, so what are the meter of the gate valve? Please refer your supporting document. And then for flow rate and velocity, just leave it blank. And for equivalent length, this as I mentioned before during part 1, when you doing a piping, there's no equivalent length and quantity. But for when it's come to fittings, so you need to know about the equivalent length. So please find the equivalent length from table. So okay, so this one table 10. Table 10 is valve losses in equivalent feet of pipe. So you need to refer the gate valve. Okay, let's say you have a gate valve. And then let's say your size of gate valve is also 2 inch. Same with your piping. Okay. So for the actual size, you need to refer from the supporting document. Okay. So for 2 inch gate valve, the equivalent length is 2.3 here. Okay, so put it 2.3. 2.3. Okay. And then let's say your quantity of gate valve is 3. Okay, so for total length is this one times this one. A times B is 6.9. Okay. And then for friction loss, feet water per 100 feet. So no need to put here. This one is just empty. Leave it blank. And then for next, okay, what are the fittings attached in the piping? Okay, let's say you have elbow 90 degree. Okay, so elbow 90 degree also you put your diameter here, and then flow rate and velocity is dash dash, and then for your equivalent length, refer your table. Elbow is at table 11. Fitting losses in equivalent feet of pipe for elbow. So many type of elbow here. So for your system, basically they use a 90 degree standard elbow. So let's say the piping size, let's say the elbow size is 2 inch. So your equivalent length is become 5. So put here 5.0. Okay, and then let's say you have 10 elbow. Let's say you have 10. So this one become 50. Okay. So next fitting. Okay. So next fitting strainer. Strainer just after before the cooling tower. Strainer identify the diameter. This one both dash. And then equivalent length for strainer. For your strainer, this one. Okay. This one is a strainer. Actually, they have 2 types of strainer actually. Strainer Y. This one is seems like Y, right? So Y. Okay, Y. So they have 2 types of strainer here. Either they have only one screw, one big screw here to open this strainer. Basically, we can do a maintenance for this strainer because inside this strainer it have a filter to filter all the kotoran lah yang ada dalam cooling tower. So this one is one screw, and then second type is there is many screw here, the small one. So but for this system, they only use the one big screw here. So if one big screw, refer to table 10 also.
So two type of Y strainer, either flat end. Flat end is the many type of small screw, and screw end is only one screw at the end of the strainer. Okay, and then let's say 2 inch, and then the screw end equivalent length is 14. Okay, put here 14. Okay, 14. Okay, let's say your quantity is only 1, so this one is 14. Alright. Okay, so other fittings such as event, vibration isolator, sorry, event, vibration isolator, temperature indicator, pressure indicator, and also flow rate meter. You just input it here, but nothing to do with your calculation. Okay, so it's not calculate in your calculation. Alright. So only these 4 items include in your calculation. So this one plus this one plus this one, and then let's say you get okay, let's say for example you get 250. Okay, let's say 250. And then friction loss that you have get from the piping 1.5, just bring it down 1.5 here, and then this one times this one you will get here. Okay, alright, let's say 130. Let's see, for example 130. Okay, so settle for your friction loss part. So you get 130 friction loss feet water. W is water, feet water. Okay, and then go back to your slide. So next step, after you come up with your friction loss chart, friction loss value, you need to additional 15% more from your result. So means, okay, so basically this one is not the final value. So 130 is you need to plus 15%. So additional lagi 15%, and then it will come, okay, let's say you get 150. Okay, let's say, for example, let's say you get 150 feet water. Okay, next step. So after you get this actual friction loss, okay, let's say 150, you need to select a pump selection which is appropriate for your system. So, okay, pump curve. Alright, pump curve. Okay, so for pump curve, x-axis is a Q, flow rate, in unit meter cube per hour. This one is condenser water flow rate, and then this one is H is head. H is also friction loss or pressure drop. So in unit meter. So basically you have your data here in unit feet water. So when it's come to pump curve, so you need to convert it from feet to meter. And then also water flow rate, you have from your from the catalog of the system with EWM 100 model, you get the cooling condenser water flow rate is 25.4. So that one is in unit US gallon per minute. US gallon per minute, you need to convert it to meter cube per hour. Alright. Okay. Okay, so okay, let's say after you convert both unit, both item, both parameter, you need to draw here. Okay, let's say you get 30. Sorry, let's say you get 20. Let's say you get 20 meter cube per hour, just draw straight line. And then let's say after you convert your friction loss to meter, let's say you get 30. So 20, 30 intersection means your point is falls in this region. So this region is 2900 speed. This one is speed. This one is speed of the motor. 2900 RPM, and then also 1450 RPM. Okay. So when it's come to this region, so means you need to have two models of pump. Okay. So let's say your point falls to this region. So means you only have one model of your condenser water pump with speed 1450. And this one, when the point falls to this region, so means you only have one model for condenser water pump with speed 2900. Okay, alright. Okay, so next slide. Okay, let's say you get this, this boost speed. Okay, so next slide. I provide two pump curve for condenser water pump. This one, this number inside of this each region is a pump model number. Okay, so your answer will be, you need to do like this, pump model. Example, cm is the pump range. This one is the number, the point that is reached in the what region. Okay, let's say so since you need to have two model of pump, so you need to use both pump curve. Okay, let's say 30 degree and 20. This one x and y is this also the same value you use. From this, you need to use the same value for x and y axis. Okay, let's say condenser water flow rate is 20, and then let's say the friction loss is 30. Okay, just draw this one. Intersection is here, so it's become this region. So means your pump model for speed 1450 is CM 85-315. Alright. So next curve. So same value also 20 to 30. So your next your second model of condenser water pump for speed 2900 is CM 32-160. Okay, so that one is the answer. So two model of pump you have been selected from your pump curve. Okay, alright. Okay, that's all. Okay, so for your, you need to anything document that you are using related to this lab 2. So you need to attach together with your lab report and then submit it in only one file, one PDF file through ULearn. So only one representative to upload the lab report. Okay, so you just assign one student to submit a report for each group. Alright, okay. This one. Alright. For this, you just fill in what is the procedure method, how to run the water cool package unit step by step, and then what is the work process of the in order to select the pump station. So you need to do step by step. So first you are doing what? Okay, first one, let's say example, establish the piping design, and the second blah blah blah, macam tu lah. And then so any additional info you just put here. So in order for me to marking it to get a better marks, and then for result and calculation you just put here. Alright, okay. That's all from me. Hope this sharing session is benefit for you in order for you to complete all the lab report. Okay. So just in case you have any question, just ask it in the WhatsApp group. Okay. So that all everybody will know. Alright, okay. That's all. Thank you.